This week on BSD Now, Allan is back from the latest FreeBSD Developer Summit, and we're going to get to hear his recap of the event. We also have an interview with Hiren, who's going to be telling us about his ongoing work of improving the TCP stack in FreeBSD. This, and of course, all the latest news and feedback coming up on BSD Now. BSD Now, episode 115, Controlling the Transmissions, recorded November 11th, 2015. Hey, I'm your host, Chris Moore.
And I'm Allan Jude.
And we're glad to have you guys with us this week. First of all, glad to have you back, Allan. We made it back safely from the Dev Summit.
Yep.
And I wanted to shout out, too, that it's Veterans Day here in the States. So happy Veterans Day to any service members we have who are watching or former service members. Thanks for your service. And we're glad we could be here to do this for you. I guess we don't get the day off.
Yeah,
No,
Remembrance Day is what we call it here in Canada, but same thing.
Is it the same? Is it the same day? Okay, well, good deal. So anyway, we got to hear, first of all, Allan, what happened with the Dev Summit last week. Give us your recap of that.
Lots of interesting things, presentations by a bunch of vendors, including TitleScale, which is using Beehive to take a bunch of separate machines and make one really big VM with more CPU cores and more RAM than you can physically stuff in a box.
Nice.
For those applications where you need, a lot of cores, but you can't buy a machine with that many cores, or buying a machine with that many cores would cost a lot more than buying, that many cores divided across 10 machines. Then there was lots of other vendor presentations from Intel. They have vTune ported to FreeBSD now, although so that's really cool. They talked about persistent memory, new NVDIMMs. So these are basically RAM that will go in your RAM slot, but will not forget everything when you power off.
That's interesting.
So
are they similar capacities, or are these like hard
the
drives?
capacities they were talking about were quite huge.
Really?
So basically, currently we have, RAM is this fast, and then we have SSDs and hard drives. So Intel's introduced the NVMEs with 3D Crosspoint that's coming out, and they'll basically be faster than SSDs, but slower than RAM.
Okay.
And then in between those, they're going to have these NVDIMMs, which will be kind of like an NVMe, but attached via your RAM channel. And so these will be slower than RAM, but faster than NVMe, but provide apparently storage on, they're talking about the storage gets divided into 512 gig chunks.
Oh, wow.
Suggesting there will be more than one of those 512 gig chunks.
So you get a 2 terabyte stick or something like that.
Yeah.
Wow.
And so a whole bunch of it, and it doesn't get erased when you power off.
That is crazy. There's your persistent L2 arc, right?
Yeah. And then there's a bunch of APIs for accessing it and stuff. But all the slides for it are up on the website. I'll add a link to the show notes to the Dev Summit page, and that will help you find it.
Nice. Did I saw an email somebody had sent in? Did Nosh or NoSH get shown off there as well?
I didn't see that, no.
Okay. I saw somebody talking about that.
Yeah, so there was the persistent memory stuff from Intel, the distributed hypervisor from TitleScale. Then George Neville-Neal presented about the work on the TCP stack, which is what we'll be doing our interview today about. And then the Foundation gave an update, and then Craig Rodriguez talked about the testing Jenkins and Fabricator integration.
Sure.
And then Devin Teskey and I were talking about the boot environment menu, and I talked a bit about the encryption in the boot blocks, which is mostly working now. Actually, at the Dev Summit, I added the password prompt, so you can actually boot off a pool with a password other than test now.
Do you have a patch close enough for me to play with?
Probably. I will clean it up this weekend.
Okay. Because we got, say, the December images. We still got a couple weeks. It'd be nice to slip that into there and let people start trying that out.
Then we, on the second day, we played everybody's favorite game show, Have, Want, Need. And luckily, that giant list has made it up onto the wiki, so you can see all the things that people want to talk about, and also what things people already have. Like from Panasys, they have SATA error counters that you'll be able to watch. So more kind of, even if you're not using ZFS, being able to see, oh, this disk returned errors. But even if you are using ZFS, ZFS only tells you when the drive is completely gives up and doesn't return the data or something. Whereas these will tell you when the drive has a failure, even when it retries and it works the second time. So these can be good warnings that a hard drive is going flaky and so on.
Okay.
Warner's IO scheduler from Netflix. There's apparently some UFS IO recovery stuff that is available from people, and the asynchronous send file with inline TLS to do delivering large files very quickly over SSL that Netflix has. That is going to get upstreamed. Lots of other stuff, including paravirtualized SCSI driver for VMware that would be available on FreeBSD, which will also be very cool.
Wow. So these all sound like 11.0 features, I would assume. Maybe some of them hit 10.3.
Right. These are all things people have at the places where they work or in their little project branch that hopefully will get upstreamed into FreeBSD.
Okay.
Then there was talk about things that people need, like tools for dealing with motherboard firmware to like update the BIOS and so on. When you change the MAC address on a NIC in FreeBSD, it should save the original one somewhere, so you can decide to switch back to it without having to just remember what it was. That would be cool. And there was a patch for that, but then the way we manage NICs and FreeBSD changed, like internally, the data structures, and it kind of makes the patch not work, and so that has to just be sorted out again. Then there was some questions about cross-endian UFS. Right, so if you make a UFS file system on i386 or AMD64, that's not the same as it is on MIPS.
Sure.
And some just tools for being able to deal with both of those would be cool. So apparently the kernel already takes care of it, but we want some of the user tools to be able to deal with that. MakeFS manifests and lots of other things they talked about, including getting the SM BIOS information in EFI so that we can trigger things like, I don't know what else. It makes it useful for detecting what type of motherboard you have and stuff. I know the installer uses it now to decide if it needs to apply the Lenovo fix to your computer and things like that.
Sure.
Cool. And then lots of other interesting things. But there's a giant list here. Some of them have names beside them of people who volunteered to work on that, and so on.
So how many people were at this Dev Summit?
Much off the list. I think there were almost 100.
Wow. Okay.
Yeah, there was quite a few people. Lots of different companies were represented there. Panasys, TitleScale, Mellanox, Limelight, NetApp, Cavium, Groupon, Citrix, IX Systems, Intel, Honey, Apple, Juniper had a bunch of people there. Norse, Isilon, Netflix, Chelseo, Xinuous, I don't know, Sony.
Definitely a good crowd.
Yeah, there were lots of people there. VMware was there, Netgate, basically everybody was there. And that was the point of this. It was not just a developer summit, but a vendor summit. So it was trying to get as many of those people as could to come out so that we could talk to them.
Personally, I think it's exciting to hear all those company names there because I remember it's been about 10 years now that I've been doing this, and it seemed like it was a much smaller group of companies back in the day, and to see that growth is good.
Yes. And the other one was the Intel network driver people promised to have tools for all the things that you can do on Linux with the drivers, like updating the BIOS on the card and so on.
Okay.
For the network drivers, should all be available by the end of this week, I think.
Oh, fantastic.
Yeah.
Well, hopefully that'll be in next week's show. We'll be telling you all about that and how to use those.
Yes, there's lots of notes on the wiki, and I added that to the show notes so you can check it out.
Okay. Well, great. Well, we don't want to make this an all FreeBSD show today, but we do have a FreeBSD quarterly status report to get to too, which that's almost a whole show in and of itself.
Yes, we have made whole shows out of it before.
We have. But we're going to go through some of this here today, and there's a ton more if you want to actually hit up the link in the show notes afterwards. But we'll try and get you some of the highlights here, and we'll just go ahead and kick that off here. So, of course,
no matter what you're interested in BSD, there's something for you in the status report. that's
That's
happened
right.
in the last 3 months.
It's quite a wide cross section of just all sorts of stuff happening in every corner of a BSD operating system. But first of all, here, a Beehive I saw was interesting. I know we've talked about this, but specifically they ported over the Intel EDK2 UEFI firmware, and that's specifically what's allowing you to do Windows in headless mode now, and also adds support for Lumos. But also, there was a tidbit that porting to ARM has begun. So maybe we'll see Beehive running under. It looked like ARM v7, I think, was the target they were working on there.
I'm not sure, but yeah,
Yeah,
it'd be interesting to have, be sooner rather than later to some of those other platforms as well.
that's right. That's right. Also, there was a poster mentioning about the support for the Acer C720 Chromebooks. So if you have one of those, there's been a lot of work that's gone into making that a great little platform to run FreeBSD on. They mentioned they get like 6 hours of battery life on it. So that's
Yeah,
a
and
really decent system
for $200, that's a
yeah,
nice
for a
machine.
FreeBSD laptop, that's really good. So anyway, you may want to check that out because if you have one of those laying around or can get one, like you said, Alan, for $200, you can't go wrong for that kind of
Yeah.
battery life.
Next up, we had the high availability clustering with CTL, which is the CAM target layer.
Mm-hmm.
So this was a big one for me because I'm very interested in this type of feature. But basically, when the CAM target layer was originally introduced by a company into FreeBSD, it had support for high availability clustering, but eventually that bit of code never made it out of the company before it went away.
Sure.
And so there was all this setup for high availability, but the code wasn't there. But Alexander Motin went and wrote, basically used the existing design and wrote all new code from scratch and fixed up the little bits that weren't quite right and improved it. And they now have full support in FreeBSD. And it comes
Nice.
in basically 4 different modes.
Mm-hmm.
So if you have a separate disk shelf or something and then 2 heads, you can either go in active unavailable mode, which basically means the one server is connected to the disk and the second one doesn't get a connection. Then active standby, basically the second machine probes the disks and knows that they're all there, but it doesn't actually execute commands on the disks, right? Because you don't want both machines right into this at the same time.
Sure.
And then there's basically 2 different active mode. The first one, both nodes process commands and access the backing storage, the disks, and they synchronize their state and command execution with whichever one's the primary. The secondary basically talks to it over an interlink, a protocol that Alexander wrote so that they don't stomp on each other. And then there's also active with the secondary node where it doesn't actually connect to the disk directly, but if you ask it for something, it will go over the interlink and ask the primary to go work on the disk for it and then send the result back.
Wow.
And then the post here in the status report goes on to talk about what happens if the interlink breaks down or the connection between them stops working and how it deals with that. But as part of this work, he also added emulation for CD and DVD drives and the ability to reconfigure a logical unit while it's running. So before you
that's
had
nice.
to delete it and recreate it, now you can just live reconfigure it.
Oh, that's slick.
And the code's already in head and has been merged to stable 10, so will be included in 10.3 as well.
Yeah, I think Alexander Motin did that work as a part of something they were going to put into FreeNAS 10.
Yeah. So that's IX Systems.
Okay. Well, next up here, this is something I saw that was kind of interesting, root remounting. So if you're coming from the Linux world, this would be similar to pivot root in Linux, but it allows you to do a reboot-R to do a fast reboot, essentially, where you have a partial shutdown, kill all the processes, remount rootfs, and then boot back up. So especially useful, of course, if you're booting from MFS or you're transitioning to iSCSI or some other backing storage. I'm thinking maybe even boot environments we could use this. If we don't need to load a new kernel,
Possibly. Yeah.
I wonder if I could just say, "Oh, new boot environment is the new default." Boot right back up, skipping the whole. Right?
That would be worth trying.
Because that's actually why I got really excited when I read that. I was like, okay, most of the package updates we do in PCBSD don't ever touch the kernel, right? There's very seldom do we have kernel updates, so now we can just do a fast reboot. Like, I'm going to play with that. But apparently that's landed in kern already, so that's on my list to play with here very soon.
Yes, that's even cooler. Because I know the thing it was being talked about recently was the booting from iSCSI, is that the current system doesn't can't quite handle it, and so basically you boot off iSCSI, and what you boot off of from the part that's done by the NIC would just be like a small little image file that would load your kernel only or something, and then you would use this reroute support to, after the kernel's running and it's loaded the iSCSI driver, then to reroute onto the iSCSI to get the rest of the operating system.
Nice.
But yeah, both of those seem like interesting things.
Yeah, that opens up some interesting possibilities for fast updates and fast reboots. But anyway, we'll be looking into that. I know we had mentioned before, but OpenCL support landed as well, support in the Mesa port, and they have an update on the kernel progress of the i915 driver. We actually mentioned that in the last episodes. We talked about how Haswell support has landed, so we've given you some more up-to-date info on that already. Improved support for UEFI frame buffer as well. So basically a bunch of newer MacBook Pros and other Macs now can boot properly. In addition, there was some improvements to the VT frame buffer driver. So if you have a really high resolution display, you can use that as well.
Yes, I remember hearing talk about that and some testing going on in Cambridge. It was like, oh, if you have one of the new Macs that has like a 4K resolution laptop screen, the VT driver doesn't quite work right. And then they got it working. So that's awesome.
Oh, that's cool.
And then, PCBSD has been trying it out for a while, and you said it's been working well. But ZFS support for booting from UEFI.
Yeah,
which
we've been using it for
really
about
nice.
2 months now. Let me see. I'm not using it at the moment on my laptop, but I did try it there, and it worked fine. And we've not had any reports that it's bad. It looks like it just does its thing. So that's pretty cool.
That's very nice. And then separately, a bunch of other features came in from Illumos into ZFS, including resumable send, which we've all been waiting for, receive prefetch, which means receiving onto a system will go even faster and make a better effort to saturate all those disks. Replication checksumming. Originally, if you're doing a ZFS replication, it only checksummed the whole thing at the very end. So if that was, hundreds of gigabytes and there was an error somewhere in the middle, you would replicate the rest and then at the end find out it was bad and throw it all away.
Sure.
Now each logical chunk has a checksum so that if there's a problem, you find it soon and then combine that with the resumability and you could just pick up, the block before the corruption happened and keep going, which will make very nice.
So what's this one about the less RAM required for L2 ARC?
Right. So each entry you have into L2 ARC, an SSD cache, requires some amount of RAM to say, hey, over on this SSD is where you'll find this file. But George Wilson and some others did a bunch of work on that, and now it takes a lot less RAM for each entry you have in the L2 ARC.
Okay.
And especially because the whole point of the L2 ARC is I don't have enough RAM for all the things I need to cache. Having it take up a lot of RAM is not so helpful.
To run it.
But I think originally it required like 240 bytes of RAM, and they got that down to like 100 bytes of RAM for each entry in the L2 ARC or something like that. So that makes that's quite good. And they also simplified and improved the prefetch code. So when you're requesting, when ZFS notices you're reading a file sequentially or something, it will go and get the next part so that when you ask for it, it's already in RAM and it comes up real fast. And the code was overcomplicated in the past and was trying to do things, and it turned out that most times it was wrong. And actually just simplifying it made it actually get a higher cache hit ratio most of the times.
That's good. Wasting less cycles, probably.
Yeah.
Sifting through stuff that wouldn't have worked anyway.
Yeah, or reading extra bytes off the disk and then never ever using them. Depending what it is, just because a block is next to the block you're reading doesn't mean it has anything you want on it. Yep. And then another interesting one I saw was dtrace probes have been added all over the TCP code and used to replace the old TCP debug kernel option. So if you wanted to debug something that was happening with TCP before, you'd have to recompile your kernel with this extra option that would enable a bunch of extra code that would, print out debug messages every time TCP did something. Sure. Now, those have been replaced with explicit dtrace probes, so that is, if you want to, find out what's going on in TCP, you can just use dtrace and you don't have to recompile your kernel.
Nice.
Plus,
that'll be definitely handy.
Probably looks a lot cleaner in the actual code as well.
So I wonder when we'll get to the point where that's for everything. Like there are no more debug options you have to turn on. Just dtrace it. You're good to go. Well, cool. And this last one here, which I think is kind of interesting, there's a ongoing work to bring us a native porter package of GitLab as well, which funny enough, I read that because we were just looking at setting that up a couple of days ago. And if you take a look at the quarterly status report, he's got a link to the PR where the port is already there. So if you want to go play with that, you can, and test them, give them some feedback so they can get that merged into the tree.
Yeah, for those that don't know, GitLab is basically a way to do a self-hosted kind of GitHub type thing.
Yeah. It's like GitHub in a box that you throw on your system.
Yeah. So, if you're working on a LAN and you got a couple of people or something, it's very nice to, not depend on GitHub, especially now that every once in a while GitHub tends to be, denial of service off the internet or something. Mm-hmm. It's like, we have our own copy here at the office, and that works a lot better.
Nice. Okay, well, we just kind of scratched the surface of it.
Yes.
There was pages and pages and pages of other stuff mentioned there that we didn't get to. So go ahead and definitely read that link. If you haven't already, it'll be fascinating. There's just a lot of good goodies in there that we didn't have time to mention.
Yeah, plus the crazy part is that only covers up to September.
Yeah, and there's already been so much stuff that's changed since then. So We'll be eagerly awaiting the next status report. Okay, well, next up we have Meteor. So for those who don't know about Meteor, it's a popular JavaScript web application framework. Well, it has been forked to run on FreeBSD Open and NetBSD now as well. But specifically, we have a link here where they've issued a call for testing for FreeBSD testers. And it looks like this was by Tom Freudenberg, has issued this public call, and he includes in the link all the details on how you can currently get Meteor bootstrapped on your box and bring it up on your own system. So far, the reports are pretty positive. Users are reporting it running great on their 10.2 systems or even in a jail, just fine. But also, they updated the post just yesterday saying that the OpenBSD version is ready for testing as well. So they have a prepared dev bundle for that, and you can hit up that link and get the instructions if you'd like to give that a whirl. And of course, send some feedback to those guys so they know how it worked on your end.
Mm-hmm. Interesting to see more web dev type stuff getting attention on BSD.
Well, we got more like Node.js and those kind of things starting to creep in, and It's neat to see all that stuff's making its way over. Let's see here. Oh, hypervisor information. This is always fun. So I know we've mentioned before about OpenBSD's native hypervisor that Mike Larkin's been working on. Well, he announced that it is now booting. So we have a link here to the Undeadly article, but he basically gives us the update of their hypervisor, VMM, that's what it's called. And we have the output on his Twitter post here, which shows the successful VM boot up of an OpenBSD 5.8 current all the way into multi-user. So it's pretty cool to see that that's actually happened. But while the code has not been publicly committed yet, we will, of course, keep you informed when it lands so you too can begin playing with it, and be interesting to see comparisons, between that and Beehive and see how they work. But exciting stuff coming soon, and we need to talk to Mike, so we're just putting that out there now. Mike, you need to come on here and tell us about this, because I know a lot of people have been very interested to hear how this work's been going. All right, so what's this next one we have about how I like open source, Allan?
Yes, so this is a post by Baptiste Toussaint, who's a FreeBSD core team member and was one of the lead people that developed Package and many, many other things on BSD now. He's been doing quite a bit of work. And it talks about a project he worked on recently, which is string collation. So support for Unicode and other things, and basically the set of functions in libc that allow you to compare a string. And because in Unicode, the letter A and some other letter that might also look like an A can be different, and all kinds of complicated stuff happens in there. But the important thing here is basically the story of how the string collation code ended up in FreeBSD. So it all started years ago when Gerrit Damour of the Illumos project implemented Unicode string collation when he worked at Nexenta on the Illumos. But the important thing he did was he made the code BSD license rather than CDDL, since he was writing it all from scratch. Then recently, John Marino from Dragonfly BSD imported the work done on Illumos into Dragonfly. And while he was there, he decided it'd be a good idea to update the tools in Dragonfly that define how the different localizations work, like the French and German and so on.
Sure.
When he went to do this, he discovered that Edwin Gruthius from FreeBSD had long ago started a project to simplify how that was done on FreeBSD. And so John Marino imported the work done by Edwin into Dragonfly and then updated it to the latest version of Unicode and fixed a bunch of bugs and so on. And then John Marino had worked with Baptiste quite a few times in the past, including on bringing package imports over to Dragonfly. And so when BAPT saw that John had been working on this string collation thing, he decided it was time that FreeBSD got its proper string collation support. Because there had been Google Summer of Code projects and so on before, but nothing had ever got close to being able to actually be committed. So he started working with John and importing the Dragonfly code into FreeBSD. And when he did that, he found a couple of bugs, including with the Japanese and Russian encoding. And he worked with John, who did most of the work, to track those down and fix those. And then Baptiste converted the locale-def program, which they had imported from Illumos. But on Illumos, it used libavl, which is CDDL licensed. So Baptiste converted it to use tree on FreeBSD, which is BSD licensed. So that made the code, more palatable to everybody.
Sure.
And so now we have these newer tools that are available in FreeBSD and Dragonfly for actually defining the localizations. And then he also took the updated code that Edwin had started that John extended and brought it back into FreeBSD. So now, as a result of this nice flow of patches going back and forth between Dragonfly and FreeBSD, and then now Garrett from Illumos is interested in grabbing those fixes and pulling them back into Illumos. And so, as a result of the collaboration, there are now 3 OSs that share the same implementation of string collation support, which is very good because if any one of them discovers a bug, then all 3 of them will benefit from the fix.
Nice.
And also, just string collation in particular is just not a very sexy thing to work on, not something very many people are interested in. Lots of people like to have it and use it, but not many people want to work on it.
Yeah, people notice when it's not there and will complain, but it doesn't necessarily get fixed right away.
Right, and there's not that many people want to work on it, so you don't want to end up with, somebody having to do a lot of this work over again. And so it's very good that we end up with this work being shared between the 3 projects.
Well, that's great. Yeah, we'd like to hear about that kind of collaboration happening.
It's, that's how open source is supposed to happen. Even though this contains all the typical open source things of, somebody started something years ago but never finished it. It's like, well, if it's quite good and I just picked it up and updated the version of the external thing it used and fixed a couple of bugs and now it's all good. And then the important thing was that didn't just end up only in Dragonfly. It made it back into FreeBSD and hopefully, by the sounds of it, we'll even make it back into Illumos.
Okay.
Yeah. It's a good story of successful collaboration between a bunch of projects.
Nice. Well, if you guys know more stories like that, send them our way because we like to see the collaboration and follow the history of how this tool ended up here, there, and then merged way back here. It's pretty neat to see how that all happens. We've seen presentations in the past where they visualize the code showing things that get worked on and it changes stuff. So find that stuff fascinating. Thank you for bringing us that, Allan. Okay, well, it's time here. We got to do an interview here in a moment. But before we do, we got our first sponsor to mention this week, which we're going to start with DigitalOcean. So come on, guys, digitalocean.com. You can go there. There's no /BSD Now there. And I think somebody emailed to ask us why that was at one point.
Because they have a coupon code instead.
Yes, that's right. So if you go to digitalocean.com and use the coupon code FreeBSD Now, that'll give you your $10 credit, which allows you basically to run 2 months free of a VM. Which is definitely slick. So I know I've got my Quassel client running up there right now we set up a Mumble server for gaming days and stuff. So there's just a lot of neat things you can do, and they have data centers all over the world. So I think we say New York, London, Singapore,
Germany,
there's a new one in Toronto.
There's a new one in Toronto. There's one on the West Coast in the U.S. as well. San Francisco, I think. So they have a huge number of locations now, so you can just pick where you want it to be. And they also have mobile IPs now, so you can actually 2 VMs within the same data center, and you can move an IP from one to the other, which is really great for failover or doing an upgrade or all kinds of things like that.
Nice. Well, and best yet, they have support for FreeBSD out of box, which is fantastic. And if you'd like to do OpenBSD on there, you can definitely do that as well. There are instructions floating around on how to do that. And if you're suffering and need to use Linux for some reason, you could do that as well. But definitely use the coupon code FreeBSD Now, and that works just for your account in general. So even if you have to run a mixture of different VMs, that'll still work for you. So go on over there, guys, digitalocean.com, get spun up today. And if you talk to them, let them know you heard about it here on BSD Now. Joined now by Hiren Panchasra, who's here to talk to us about TCP, and Hiren's a FreeBSD developer as well. So first of all, welcome to the show. We appreciate you being here today.
Sure. Thanks for having me.
So give us a little bit about your background. Tell us your story. What kind of brought you into the BSD world?
So yeah, when I joined Juniper back in the day, that was my first BSD exposure. A colleague of mine helped me set up a FreeBSD desktop, and the thing that attracted me the most was lean base and pick and choose ports. That was the seller for me, and I the whole idea. So I used to be an Ubuntu user before that, and
I'm sorry.
yeah, we all have been there, I guess. So uh, when I came to FreeBSD, the thing I liked was I exactly knew what was running on my computer. So
Hmm.
that's that was my reason for getting and sticking to FreeBSD. And of course, I was working on userland things and config managements and whatnot for Juniper back then. There was a lot of C, so yeah, that's how I got into BSD.
Okay.
Cool. So how did you end up becoming a FreeBSD committer?
That's a funny story. So uh, yeah, so one of the projects I was working on there was to do with a lot of string processing. We were doing syslog parsing for better data extraction and whatnot. And one of the platforms that I was supporting was a pretty low-end platform. So I wanted to get the most juice out of it without all the processing being sucked into the string processing part. So I picked up a C standards library book to see what all I can do, what all I have in terms of library calls and whatnot. And I was reading that book on my way to work on the bus. And apparently, Peter Wem and Sean Bruno used to take the same bus for their work. And Sean saw me across the seat and reading this book, and he actually made a comment that why are you what are you doing reading this C book? Isn't everything running on Java now? And so that's how we met, and he roped me into different things, and so I always wanted to work on open source, but I didn't know how.
Hmm.
And Sean has helped me tremendously over the years, and so that was the start. So we started, I guess, working on libvirt and port for that for FreeBSD. Uh, and there was some licensing drama, and they didn't want to get our patch back in and whatnot. So yeah, that was that. But that was like the thing that got me started into actually working on FreeBSD related things, and yeah, and then BSD can happened in 2012. Yeah,
Hmm.
and foundation gave me a travel grant to go to that, and that was like the thing that clicked. That I met the community, and that was pretty amazing experience. And before I knew it, I was actually working with Sean and Peter at Yahoo.
Hmm.
So yeah, and then I started working on HWPMC first. So at Yahoo we had a bunch of new processors, and I wanted to port HWPMC support for them. And yeah, that's how I started poking at HWPMC,
Yeah.
and somehow Sean managed to get me a commit bit.
Right.
So
He wrangled that into a bit for you. Well, that's cool.
yes, yeah.
So we'll come back to the HWPMC in a little bit because I want to ask you just questions about that. But we're here
Sure.
to talk mainly about the TCP stack, and we hear you're working on a bunch of improvements there. So what exactly is going on?
Sure. So we have. So I am not doing anything alone. So we have this a new effort that we have started with bunch of people to improve transport protocols and mainly TCP right now. And so we have a mailing list, FreeBSD-transport for that. We have wiki for that, FreeBSD.org, wiki.freebsd.org/transport protocols, and we do weekly calls also. So we talk about TCP improvements on that and how to bring those into FreeBSD. So
Mhm.
it's kind of a multifaceted problem. So one thing we have is we are lacking a bunch of newer RFC support, and so we are known for the stability part of FreeBSD stack, right? The
Sure.
TCP is pretty stable. So there is a lot of resistance to change also. So we are attacking this from two angles. So trying to bring in new RFCs and trying to make it where we can bring in new work without much disturbance. So those two things are going on in parallel. A change is in review in Fabric right now, which can let you bring in your, for example, TCP output, input, segment processing, your own code as a module, and load unload that on runtime. So that will make sure that existing things won't break, and you can still bring in new things. So that is one part. And another part is we are looking into a bunch of RFCs. So we have a list of RFCs that we support or don't support, and we are trying to measure right now that what exactly are we missing, and what is the most important thing that we need right now, and going through that and bringing those in via smaller reviews and whatnot. So that's been going on.
I saw there's a big list on that wiki that you mentioned of the different RFCs and whether they're supported or if they're only informational, so they don't need any code. And then there's
Right.
quite a few that are just listed as unknown. It's like, do we actually do that or not?
Right,
I
exactly.
know,
So
I know.
yeah, exactly, right. So that's another problem. So how do you exactly know? You have to go and read the code. Even then, it's kind of difficult. So that's why this is a group exercise that we go through. And so my work right now wants me to work on that. So that's good. That's what I'm looking into. So I'm looking into mainly right now the SAC related improvements. One thing I've noticed is we don't react well to loss. So that is something that I want to improve and fix. And there are other things also going on. Better RTT support for data center TCP is something that's going on, and there is a list of things that we are working on.
Yeah, so that kind of goes into the next question. So, like,
Yeah.
do you know what are some of the new RFCs or features that the group is planning to actually implement?
Sure. So currently in discussion is the latest SAC recommendations, that is 6675. So how do you, so the idea is, let's say you send 10 packets and one gets dropped and you get a SAC saying that 9 made it through. So you need to get that information and calculate how much is in the network so that you can decide how much more you can send on the network to use that most efficiently. So 6675 is one. There is another following RFC, which is proportional rate reduction, and that is a 6937. So basically the idea is the you drop a packet and you half your congestion window and SS thrash, and you try to bring your speed to that. So proportional rate reduction helps in adjusting that so that you don't see a lot of flickering in your congestion window. So different things like that. The subtlety here is how to test those things. That's very tricky in TCP land. You can sure you can test on your local setup and whatnot, but things look really different when you put that same thing onto production. So
Yeah, and then
Okay.
also once you get into doing production stuff, it's like, well, how do I see only one of these happening at a time? And
exactly.
it's like there's no
So
such thing
yeah,
as a quiet wire anymore.
no, yeah. So yeah.
Okay. So why does a FreeBSD's handling of out of order TCP packets really matter in this case?
Yeah, so that's kind of funny. So that was one of the first things that I've started noticing at my current work, and I started looking into it. And and it's a bigger rabbit hole than that. So if we think about this, right, how we detect loss right now on TCP. You send a few packets in, you wait for ACK. There are two ways you detect loss. You either get decided amount of duplicate acts, which is 3 for us right now, or your retransmission timer fires. So you don't hear anything back, and your timer fires, and you start retransmitting, and taking that as a loss. So thinking about that more, like why number 3? What's important in 3? That's just an arbitrary number that we have picked up from older RFCs and whatnot. So sometimes it happens that your network is as such, you get reordering of degree 5. What I mean is, when you send let's say you send 10 packets, and ACK for packet 2 comes after ACK of packet 7, for example.
Mm-hmm.
So that's reordering of degree 5. So should we after that decide that we will always wait for 5 due packs instead of 3, or is it too late for you? Or so the whole gist is TCP is very precise until a packet comes out of order, and then it's all a guesswork.
Mm-hmm.
So based on different things that you want out of your stack, you need to make these smart decisions. And that's why this problem is very important. So do you are you is your application a media sensitive media application where you don't want any old data? So delayed ACK is no good, or you rather wait for those ACKs to come back to you than do a spurious retransmission. So so
Yeah.
so yeah, and there are many recommendations for that, and many RFCs which talk about that. But again, getting those right to which match with every flow you have on internet, or everything you want to serve out of your box is rather critical, and very complex. So
Okay.
yeah, so that's those are the things that we are looking into right now. So Linux does that. For example, if it detects that reordering is higher than 3, then it adjusts that due pack threshold, so it doesn't retransmit on 3 due packs. It waits for that degree to happen, just waits for packets to come back. But then again, there is a quirk in that if it goes too high, then they switch to some other algorithm. So things like that.
So it sounds like some very challenging work on top of very interesting.
Yes, it is. And that's why this whole group effort is what is working really well right now. So we get to discuss actual problems, and we can ex- poke people on phone to go look at a review, or do a test in their production for a patch that's going on. So yeah.
So how does the FreeBSD TCP stack compare to some of the other BSDs or even other operating systems that might be open or closed source?
So I did a lot of digging lately in last few months around that. In With respect to other BSDs, I guess FreeBSD is the most updated stack that I have found, with minor exceptions. The whole general idea is you look at RFCs and recommendations and try to do that so that the internet doesn't fall. But not everybody does that. So I've seen other quirks in different stacks. I've seen one in NetBSD where they are not strictly following RFC, but that behavior looks better. So things like that. But in general, FreeBSD has most up-to-date support and whatnot. OSX is a little better, in my knowledge, and Linux has much more recent support. So that I'm looking into that right now to see how they are managing all these things, and mind you, that makes tuning Linux stack that much harder because you have more things to take care of.
Sure.
But but that doesn't take away from them that they have more RFC support and whatnot.
Okay. So what are kind of the outstanding bug lists that remains to be fixed right now?
There are many. So if you look at the RFC list, there are a lot of them. But again, the trick is we don't have all the time in the world. So we have to come up with the most important things to fix right now. So for me, I am more interested in the loss recovery part and congestion control part. So I'm looking at a CCCDG that's from Kaya Swinburne University. That's a delay-based congestion control. Because networks have, especially because of wireless, things have changed now. Packet drop does not mean now what it used to mean back in the days. Packet drop can happen without congestion. So reacting to a drop in a fatal manner like we do right now. For example, right now you see a packet stack sends a packet, it sees a packet drop, and it goes belly up and reduces its congestion window and all that things. That's not the correct behavior right now. So loss-based congestion control algorithms would do that, and uh, we need to look at more delay-based algorithms right now, which also considers loss after some point in time. So CCCDG is very interesting to me. So that's something I'm looking into. So that's the congestion control part of things. The core TCP part. So one of the interesting things that's broken right now is we don't detect loss fast enough. As in when we have SAC data coming back, we don't. So basically, when you're sitting there, you are waiting for a dupec counter to go up, and when it goes up to your limit, you start retransmitting. So that incrementing of dupec counter is not correct right now. So that is another thing that we need to fix. So small things like that, which can gain us a lot of performance boost.
Another one I heard about at the vendor summit was apparently the core stack itself and the pluggable congestion control modules can sometimes be fighting each other about what to set the congestion window to.
Yes, that's so, and yes, that is a problem, a very valid problem per se, and that also exists in other stacks also, the same thing, and it's partly historical. Back in the day, when New Reno was there and whatnot, older CC algorithms were just setting the SS thrash, as in when loss happens, this is your limit. You go do slow start, as in your exponential growth of congestion window to this limit, and after that you do incremental. You don't do the exponential increase in congestion window. But later congestion control algorithms change that, and so that's where the confusion is. Right now, almost all the stacks do that, stomping on each other. So that's going on. Actually, there is a proposed RFC or a proposal out there right now. They call that laminar TCP. So the idea is, so right, it's pretty radical idea. As in, right now we have two things we track: SS thrash and C wind. The idea is to only converge to one, and try to track that, as in your sending rate. What is your sending rate? And just try to track that and get the correct value out of that. That will stop this stomping of via stack and congestion control on two different things. But that means that you have to change all things you track right now, in terms of entire TCP stack. So
That's a big change.
That's something that's going on. Yeah, it is, and you basically, all the tools, if you look at anything, all the things that graph your TCP sessions and whatnot, they all look at two different things. So
cool.
Yeah.
So you recently just returned from a Internet Engineering Task Force conference. What sort of topics were discussed there, and what did you do?
That was, I missed the vendor summit. That part sucked, but IETF was pretty awesome. That was my first IETF, and it was pretty interesting. I've been to a bunch of BSD camps now, and this was more, of course, more focused on networking things. And the main takeaway for me was that we still don't know how internet works. So
Right.
there are, so
The aliens run it.
exactly. So so basically the a lot of talks were centered towards middle boxes, as in, so middle boxes is something that you don't control directly. They've been there for years. They don't get updated. So anything that you want to bring new into TCP, how do you go and make those middle boxes behave correctly? For example, they don't let a lot of UDP traffic go. If you add new shiny options to your TCP, they drop that. So things like that. That was a huge topic of discussion there. That how do we get correct data out of entire internet and try to tune things based on that. So because we don't have that right now, all we are doing is trying to do the guesswork and come up with the best standards we can. So if we have more data, then we can decide better. but then that brings the whole notion of privacy, that how can you extract or get more data without breaching the privacy and whatnot. And the other topic was security that was discussed pretty well. There are standards that's in works that can do like TCP ENO encryption negotiation option that you can have in TCP itself. So you do your exchanges and whatnot right when you do your three-way handshake. So that was interesting. So yeah.
That sounds like a neat conference.
Oh yeah, it was a lot of TCP talk, and it was fun.
Okay. Well, I did say we'd come back to it. So HWPMC, I know you started on that.
Yeah.
Just explain to us a little bit about what that is and what it was used for, why that kind of got you into BSD in the first place.
Yeah, so uh, we've had that for like a few years now. It's I think from 6 or 7, previously 6 or 7, and so basically CPUs expose a bunch of counters that you can poke at to look at a different performance matrix that you care about. So HWPMC, hardware performance counter measurement, is a tool for that, and there is a library libpmc that comes with that. So whenever a new processor comes out, they have this list of things they support or don't support, and you go and poke at those bits. There are user-led tools available for that, PMC stat. So you can you can see how many cache misses you are seeing. There are two basic modes. You can have system-wide sampling or a process per process sampling. So you can take a process, run PMC on that, and see how it's doing based on different criteria. So that was kind of my gateway drug to FreeBSD, and that led me to being a committer. That we had a bunch of new processors, and I wanted to work on that, and yeah.
Okay.
Cool. So one of the questions we started asking people now, since it seems to be so important, what keeps you motivated to work on open source stuff? You know, to spend your free time working on this stuff.
I think the hobby part. That's probably the most important thing for me. As in, you don't have to work on open source. You can get away from that, and nobody forces you to do anything, but you do it because you like it, and that's where you get the best results out of anything in general. So I would say the hobby part of open source is what keeps me going, and I wouldn't lie, it keeps me employable. So
True.
That does help.
yeah.
Right.
But yeah.
So you met. Oh, go ahead.
Yeah.
No, go ahead.
I was gonna say, you mentioned hobbies. Do you have any other hobbies outside of open source?
I like to run and go play volleyball and badminton and things like that, but I have a 1-year-old daughter now, so she keeps me more busy.
Oh yeah.
Yeah, so
A lot less
but,
sleep than
yeah.
before.
yes.
Oh.
Yeah.
Was there anything else you wanted to add?
Not really. Just a shout out to people who care about FreeBSD and TCP. That join the mailing list, and if you want to join the call, that'd be awesome. You can reach out via mailing list, and we can add you on the weekly call. We talk about this on Thursday mornings, and people from all around the world join, so we can adjust the timings based on that, and raise issues, and let's fix this.
Okay. Well, great. Well, thank you so much for spending the time with us today, Hiren. We really appreciate that.
Yes.
Oh, thanks a lot. Thanks for doing this. This is amazing.
Oh,
Thank
you're
you.
welcome. Okay, we're back from the interview. Hope you guys enjoyed that. It was a lot of fun, and we'll look forward to seeing some of these TCP changes landing here in the near future. So, of course, we got to get into our news roundup, but really quick before we do that, we do want to mention another sponsor this week, which is going to be IX Systems, and the URL for that is ixsystems.com/BSD Now. So you can go there specifically, get in touch with them, and they'll be able to know that, hey, you heard about it here on BSD Now, and we appreciate that. They like hearing that there's a lot of BSD Now listeners out there talking to the IX folks. But we mentioned here a couple weeks ago that they were doing a mission complete contest, Allan. It looks like they have some winners announced for October.
Yes. So
fill us in.
Yeah, so Mission Complete is where you write in and tell them your story of how you used, FreeBSD or ZFS or your FreeNAS or whatever to save the day or get some bit of work done or whatever it is you have a story about. And you get entered to win a prize each month. And for October, they had so many good submissions that they picked 2 winners.
Okay.
So the first winner they have here is Justin Var, who uses his FreeNAS for a optical media duplication system. So he uses it to basically stamp out CDs, DVDs, and Blu-rays. And so, sometimes those data sets are 700 megs for a CD or 50 gigabytes for a Blu-ray. It's important that the data actually come out exactly right? If you get any, a random bit gets flipped on your hard drive or something, and then now you've just burned, 100 Blu-rays that are wrong.
Yeah.
And that's not any good. You're selling these discs to people, right? Yeah. And so they really appreciate using ZFS and its, checksumming to make sure that, the bits that are being fed to the burner are exactly right. And so far they've shown that over the time they've been using it, that FreeNAS has never been the fault of any data errors they had.
That's great.
It's nice for them to be able to know that, ZFS made sure the data got to the burner right. So if it's wrong, it's probably the burner that's actually defective or the blank disk that was. And it helps them track down any bit level errors a lot faster because they have a file system that they can trust.
Okay.
And they go on to talk about building that out and so on. And then the second winner was Todd Russell, who uses it for a small college. They have about 140 students, and all the staff and faculty and so on, and they have actually a fair number of machines to support. And so they currently have 4 FreeNASs, including a new one they just freshly got from IX. And they use rsync to back up all the machines to 2 different FreeNASs. And then the first of those FreeNASs then syncs to a third FreeNAS.
Okay.
And they're doing that, although they do mention that they are using rsync with its backup directory option to create the date-separated archives for each file on the FreeNAS when they're backing up from the first to the third FreeNAS. And it's like, well, somebody should tell them about ZFS replication with snapshots.
I know, right?
Because on top of being much faster than the rsync, it will actually save more space. Because with rsync backup dir, if you change just one block of a file, it has to store the whole file a second time. Whereas ZFS will only have to store the change blocks, but still be able to give you both versions of the file. And then they talk about their primary use of FreeNAS is just as a CIFS server, so because most of their end users are running Windows or whatever. And with FreeNAS, you can actually integrate your ZFS snapshots into the volume shadow copy stuff built into Windows. So that if you right-click on a file or a directory, you can go and look at previous versions and actually see the older versions of the file. So if somebody accidentally deletes or messes up a file, they would be able to self-service restore it themselves rather than have to go to the administrator. So while their story is very cool about the way they're using it, FreeNAS actually makes it even easier than the way they're doing it.
That's nice. That's nice. So very cool. Glad to see that these guys won. And I think it looks like, how many months are they doing this for?
I don't know that they've decided how long, but so hurry up and write your story for this month so that you can win.
Yeah. About halfway through here, guys. So get that in. Send that in over to IX Systems. And if you talk to them, mention that you heard about it here on BSD Now. And give us the credit for it because come on, we're all awesome.
We're looking to see our name in one of those stories.
That's right. That's right. Okay.
Yes,
well, let's
if you want all your FreeNAS swag and your Amazon gift certificate, make sure you write in this month.
Okay, well, let's get into the news roundup. So first up, Libra SSL. Man, these guys just keep on chugging along, but it looks like the latest release has landed. This is a 2.3.1, which is the second snapshot based upon the OpenBSD 5.9 development branch. Nice. So it looks like also they mentioned they're currently targeting having a stable API sometime around March 2016 is the guess at the moment for the 2.3.x series. But so things are still changing and in flux. But included in this update, some ASN cleanups and some compliance fixes for RFC 5280. They switched internally to using time T, and they have checks to make sure that the host OS supports 64-bit time T.
Yes, that was the topic of a talk Theo gave as the keynote at the EuroBSDCon in Malta, which would be 3 years ago now. But very important thing because as especially BSDs get built into embedded devices like things like pipeline controllers and oil fields and so on, those aren't going to get replaced anytime soon. And when our time T hits the current limit in 2038, that's going to cause a lot of problems.
Yeah, things will change.
Some of these embedded devices get installed and don't get refreshed for 20 years. So we have to make sure that all these fixes get in now so that when devices are built 5 years from now, they actually have the fix so that 20 years after that, they don't, light the world on fire.
That's right. Don't mysteriously break. Okay, it looks like they had a slew of other TLS fixes as well as the ability to check certification validity times with TLS peer cert, not before, not after. They fixed a reported memory link and object underscore object to text. So yeah, it looks like a whole slew of good stuff here. It looks like there's a patch up somewhere. Barnard's working on getting this put into FreeBSD as like a LibreSSL develop port. And we'll probably turn it into PCBSD here soon and get that out as well. We've been running 2.3.0 for a while, and that's working pretty well. But hopefully we'll have 2.3.1 now here soon too.
I also see that they removed the broken check desk key thing that we talked about a couple weeks ago. Or I think it was on the show. Maybe it was on TextNav, actually. But basically, there was code to check for weak desk keys that had been built into OpenSSL in 2014. And due to basically a typo, it had 2 exclamation marks instead of 2 pipe symbols for OR. The code never compiled. Not once since 2004 did it ever work because of the typo. But because it was if-def out, it's obvious that no one has ever used it in the last 11 years.
Oh, man.
But when the bug was found, OpenSSL just fixed the bug by switching it to the double OR thing. Instead of being like, nobody's used this in 11 years. And it's for an old thing that nobody's going to use. Maybe we should just get rid of this. But no, they kept it. LibreSSL ripped it out.
Okay, well, good for them. Got to yank out more stuff like that.
And I also see that they enabled Netcat with SSL builds on more platforms, which is always nice.
Yeah, that's good.
Netcat's a great tool. And I didn't know that Netcat in FreeBSD is actually sourced from OpenBSD's fork of it.
Oh, interesting. I didn't know that.
Neither did I until I went to update the man page.
Okay. Well, there you go. So, yep, we'll keep an eye out for that. Or if you're on OpenBSD, hopefully you can grab that soon. Let's see. So next up, we found a guide here for installing Ghost with Nginx on FreeBSD. And you're probably like me. At first, I was like, what the heck is Ghost? Is this some other operating system? No, it's a blogging platform. So think WordPress. Matter of fact,
I think the big difference is this one writes out static files. So when you're actually serving the files, it doesn't have to run any code, which makes it more secure than something like WordPress.
That's right. So it's a MIT licensed blogging tool. It was started 2012 by a former WordPress UI developer. So it's entirely a Node.js. So that's kind of the backstory of what it is. However, there's not a port for it for FreeBSD yet. Somebody may have to do that here in the future, but this tutorial kind of walks you through the process of getting it deployed manually. And since most of the requisites are in the ports tree now, it makes it pretty simple to do. It's installing things like Node, NPM, SQL 8.3. And with all those installed, then it walks through the rest of the steps of creating the username and the home space for Ghost and some of the NPM setup commands. But the walkthrough, which I thought was interesting, even goes to all the trouble to have a handy rc.d script ready to go. So it seems like just turning that into a port should be the next step here. And then it's just package install Ghost and done. So hopefully that will put the call out there and issue a challenge. Somebody who wants to do something. This is pretty much a port done at this point. Somebody just needs to do the last couple bits to turn this into a port. But
I've been corrected by the chat room that Ghost uses an SQLite database and rather than generating flat files. But it's all done with Markdown, which is very nice. Okay.
Very nice, very nice. So yeah, so if you'd like to experiment with that, throw that in your DigitalOcean jail, for example, you can now do that.
Cool.
Okay, this next one here, it looks like Adrian Chad has written something up on his blog here, Allan. So why don't you fill us in what he's talking about here?
Yes, this is why attention to details matters when you're a kernel developer. But he is working on some Atheros MIPS 11N devices, like the little Router Board Pro or Router Station, or like the TP links that we all bought at BSD Can, and trying to get their bridging performance to be faster. He says with the Router Station Pro with a pair of AR9160 NICs, he can get about 150 megabits of bridging performance. But when he was trying on a different machine he was playing with, he was only getting about 120. And he was like, when he originally did it, that was fine. But nowadays, that's not fast enough.
Yeah, that's
people have internet connections faster than that and need to be able to go faster. So he started looking at it, and he found that using the previous work that George Neville Neal had done in getting the HWPMC code for MIPS 24K, using that as a starting point, Adrian managed to get HWPMC working for MIPS 74K, which is what these little router devices are. So now they have the performance monitoring counters. Then using data collected from the performance monitoring counters, Adrian was able to figure out why things were so slow. It was turning out that on both transmit and receive, the packets were having to be completely copied to be realigned to meet the requirements of the NIC or of the FreeBSD networking stack. So that was a lot of extra work on every single packet. It turned out that the alignment requirement for the NIC wasn't there anymore, basically. That only applied to old like Atheros 7000 NICs, and all these are on 9000s now. So in that case, that bit of work can just be skipped. And so now it's 180 megabits instead of 120, which is a bit better, but yeah.
Not phenomenal.
Yeah, so that's for the transmit side. On the receive side, the FreeBSD TCP stack requires strict alignment, and that was a problem. Someday we'd like to go fix that, but right now that's what it is. But it turns out the Ethernet stack in FreeBSD isn't as picky. So by just offsetting the pointer where we write the data from the incoming packet into the buffer that we're going to pass to the kernel, offsetting it by 2 bytes, now the Ethernet frame is misaligned, but the TCP one lines up properly. And that's all the kernel cares about. And so now, problem solved. Or not, as it turns out. After that fix, it turned out there was no performance improvement. It's like, well, damn it.
What's going on, right?
So then I kept digging and found the problem might be in the bus DMA code. But luckily, Ian Lepore had recently made a bunch of improvements in this area on ARM v6 and was helpful enough to port those over to MIPS. And now, all of a sudden, 420 megabits per second. It's like, okay, now we're getting somewhere.
Yeah,
right?
It's significant now.
More than tripled the performance. So, we're doing okay. So then he kept looking, and with that patch, people started noticing some stability problems as well. So after digging into it more, he added a missing sync operation that wasn't happening. So a bunch of stuff was being sent to memory, but without the sync to happen and wait for it to all actually arrive there, when the hardware is trying to read it, it would sometimes run into bits that hadn't been updated yet. So fixing that solves some stability problems, and switching the memory caching from write through to write back improved performance quite a bit more. And then the other problem was that now things were happening a lot faster, which was the goal of this, right? But the way the hardware works is basically has this linked list of descriptors that are in a ring. When you get to the very end, it loops back to the first one. And it goes until it finds one that's not marked as ready. But when you're sending a packet that has to be split up into a bunch to fit, if you write out the first chunk and the second chunk, and while you're working on the third chunk, the ring would come around and find your packet and be like, oh, and start transmitting it. But then run into, in the middle of it, you hadn't finished writing it all out yet, and this would cause the problem. So the workaround for that was when we mark the first one, we mark it as still being empty, though, until we've written out all the successive chunks. And once the whole packet's there, then we go back and mark the first one as ready, and now it gets transmitted. And this prevents the craziness from happening.
Okay.
And with all of that, MIPS can now bridge 720 megabits per second, which he doesn't actually say, but in the previous numbers he was talking about how it's slower than Linux, and now he doesn't. So it's at least on par, or if not better than Linux. So that's quite an improvement, though, going from 120 to 720 megabits. And he also notes that it can route at 320 megabits per second as well.
Was this just a weekend project? I'm wondering how long you spent on this.
I'm guessing more than a weekend, just because it involved other people doing stuff as well.
Sure.
But a series of weekends anyway, and he's done quite a bit of work. And so he would like to improve the routing speed as well to get that up from 320 closer to the bridging speed. But, as always, free time is scarce, and, Adrian's in the middle of switching jobs at the moment, so I don't know when he'll have time to work on that. But it's nice to see the improvements that we have gotten from him already, so.
Okay, very cool. Okay,
Next up. If you want more details on that, they're up on his blog.
Yep. definitely go check that link out if you want to find out exactly how I did it. Maybe you can help work on getting that routing speed up. Okay, so lastly here we got an article about switching from OS X to FreeBSD. And so this story, of course, is of a user who's used OS X pretty much since its beta, but he said in 10.9 and 10.10 he became more and more dissatisfied with it. They said they were spending far too much time just fighting with the system rather than actually getting any work done.
Yeah, like things would kick off in the background and use up all his bandwidth or all his CPU, or he'd disable something and it would get re-enabled by itself or by the next update. And it was just, I know a lot of OS X users have been complaining recently that the newer versions have been not as good as the older ones.
Stop doing that stuff. But anyway, they covered their process here where they went and got a new workstation bot and then the process of getting FreeBSD going on it. They also mentioned why they chose FreeBSD rather than PCBSD because they just wanted a really slim system with nothing extra special installed. They don't need all the GUI sauce.
Right, and they didn't want things like, the OS updater running in the background and doing things.
That's right.
Which,
that's right.
When I set that up on the workstation in our office, that was one of the goals is I wanted all of that stuff. But that machine has a mirrored pair of old Western Digital Raptors, like the 74 gigs, which I think the second generation of Raptor ever. And they make a lot of noise when you get busy on the disk. Really noisy disk. So you can tell when one of those OS updates kicks off because you just hear this like grinding noise from the hard drives.
Doing stuff. That's funny.
But
okay, well, they also covered setting this up on the Lenovo X220 laptop as well. But in this example, it looks like they set up i3WM and MUT. So pretty basic stuff here. But the blog post is pretty detailed, and there's links here, it looks like, to GitHub, a repo of all their configs and dot files for running FreeBSD as a workstation on their box.
Which I think included some stuff to making it a little more OS X-like to ease the transition if you're coming over from OS X.
Yeah, so you definitely want to go take a look at that, especially if you end up like having an X220 or something. You might have some fancy setup for that. But their needs were pretty basic. They just needed a terminal and OpenSSH, really, and that's all you need for work. So, that's a great reason why you can switch to FreeBSD. Oh, it looks like he mentions having a web browser media player as well. But, still a pretty thorough write-up here on what they did to convert over.
Yep, including the disabling the HT mode on the Wi-Fi to work around some of those problems. And pretty much has everything you could expect to run into setting up BSD on a desktop or a laptop. So I thought it was a good write-up. He mentions the one problem he has is he uses 1Password and was having some trouble getting that switched over or working. I know that I used LastPass on BSD and it works very well.
Okay. Well, he did mention, too, he couldn't get ZFS to work on the 220 because of UEFI.
Right. With the newer fix, that should help. But also, I don't know when he did this originally, but if he's using 10.2, it should work in BIOS mode with the patches that I got into the installer just in time.
Okay, it's time. We got some Beastie Bits for you. Lots of little stories to mention real fast, and we got feedback and questions. But before we get started, real quick, we do want to mention TarSnap this week. And of course, the URL for that, it's kind of obvious, but tarsnap.com/BSD Now. You want to go there and get signed up and start doing your encrypted backups right now. I mean, you could go ahead and get signed up. I mean, if you pause the show or just keep it running, you could probably get all signed up and have your backups automated and running before we wrap up here. So it's really not going to take you a lot of time. Making an account simple, put a few bucks in there, and you'll be surprised how long that lasts because it is dirt cheap. I know, Allan, you've been doing backups for a long time. What have you spent? A couple bucks at this point?
Not even $2 yet.
Not even $2, yeah. It is definitely cheap and worthwhile, and it's because it's backups for the paranoid. If you don't trust binaries downloaded from a site or even packages, just go compile it yourself. Source code's up on the site. You can audit it, make sure it does exactly what it's supposed to be doing, and compile your own versions and run your own binary. So come on, how cool is that? If they're that paranoid, you probably should be trusting them with your data. So,
And then TarSnap has updated their testimonials page, including a new testimonial from Robert Morris, the original author of the Morris worm, the first internet worm, back in like 1988. And he's a professor at MIT now, but he mentions that TarSnap is the most cleanly designed and convenient of many Unix backup schemes.
That's great praise. That's great praise. So again, come on, if he's trusting it, you should probably be too. So go ahead to hit on up tarsnap.com/BSD Now. And if you talk to Colin or anybody over there, let them know that we sent you. Okay, so first up in the Beastie Bits, we're going to just roll right on through these, but these may be interesting. So if you see something or hear something that sounds neat, you may want to go check it out afterwards. But first up, we have a neat article over at scale.com talking about the stack behind Netflix scaling. And actually, it's a pretty complete article. I was surprised how big it is here. But of course, they mentioned the Open Connect and FreeBSD and just all the different bits they use to make Netflix happen.
And some giant thing that keeps popping up over the screen while I'm trying to show it.
Oh, stupid ad, stop.
No, it's just their Twitter account for some reason.
Oh, okay. Fix that.
I don't know if it's just where I'm hovering my mouse or what, but anyway. They talk about the whole technology stack that they use there and all the different tools. Let's see if I can.
Yeah, definitely a neat one to read. So if you're curious to see how Netflix does their scaling, who some of their content partners are, and they have a picture of the Open Connect. I think was it in Europe or Paris or something? There was a picture of their server rack there. But check that out.
I talk about how for applications and data, they have Java, Python, JavaScript, MySQL, Cassandra, Oracle, etc. Seriously, I don't know what's in there. But the different API tools they have, what they use for DevOps, GitHub, Jenkins, Sumo Logic, etc. But the Open Connect is FreeBSD, Nginx, and Bird, the BGP daemon.
That's right. Okay, well, next we want to mention, it looks like the Amiga port of NetBSD now has Xorg support.
Wow.
So, if you've been pining away, waiting for that Amiga port to finally get X, well, guess what? Yeah, your day has arrived. So check that out. I'm not sure how many people would use that, but hey, NetBSD can do it, just like most everything. And speaking of NetBSD, it looks like they've announced the end of life for 5.x is going to be November 9th. So actually, that was a couple days ago. So
that's just their standard policy. Once 7 comes out, 5 is EOL a month later.
That's right.
It's interesting that they give 1 month of overlap. I know with the new FreeBSD scheme, I think it's 2 or 3 months of overlap before the old version goes away.
A little bit more time.
But at this point, it's if you're still on 5, you've completely missed that 6 has been going on for years now, and 7's out. You really should upgrade.
Yeah, so consider that your notice that you should probably spend some time aside this weekend and get your NetBSD boxes upgraded.
I don't know if they're just trolling, but somebody in the chat room was like, "Oh wow, really? I just threw out my Amiga yesterday because it wasn't working."
I know, right? It was like it had so much life in it, and I was so excited to use it again. But yeah, no. Okay, well, speaking of retro, kind of older things here, we have a neat port that's hitting FreeBSD called RetroArch, which allows playing PlayStation, Sega, Atari, etc. Basically lots of ROMs on FreeBSD, and we have a link to the mailing list post. And I think, is there a port linked there as well?
So they have a link to the Bugzilla where they have a patch that creates the ports. They're not committed yet, but they're available there.
So hopefully pretty soon we'll see that land in the ports tree, and then it packages proper.
Yeah, and that provides a number of different cores for the RetroArch engine, which will let you play all these old games. Sounds cool.
Oh, that is pretty neat. Okay, well, next up here we have OpenBSD. It's not really an article or anything. It's more of a big GIF, but it shows OpenBSD booting on a 75 megahertz Cyrex system with 32 megs of RAM, a whopping 32 megs of RAM, which is pretty cool. So, again, a lot of old stuff here. Maybe you have one of those laying around. Well, put OpenBSD on it.
It's the 586S 75 megahertz.
That's rocking.
With a BIOS from 1996.
Yes. I remember when I was watching the GIF, I was like, I remember those slow, painful days where it actually counts the memory.
Yep. You can still make your system do that if you go in and disable a bunch of the quick boot things.
Yeah, if you want to. Wow, crazy. Okay, well, next up we have some information here. It looks like in NetBSD that the Nouveau driver, the NVIDIA driver there, can now support GL with the latest commit that went in. So if you're rocking a newer version of a NetBSD, you have an alternative now. You can run, looks like the open source NVIDIA driver. So check that out. And then, of course, last but not least, we have some releases, which of course we have to mention. So we got two pfSense, we have pfSense and OpenSense releases back to back here. So OpenSense 15.7.18 was released, and then pfSense 2.2.5 was released.
So the
maybe uptype.
The OpenSense one is to fix the NTP regression that FreeBSD had, where the newer patch version lost a local patch that had been made in the previous version that fixed a thing where NTP would crash. But I also noticed that it added seamless integration for virtualization, so there are now packages for VMware and Zen that you can install to get the guest tools or whatever on OpenSense.
Okay.
And then
how about on the pfSense side here?
The new version fixes some cross-site scripting vulnerability in the web UI, does the NTP, BSD patch, and OpenSSH patches, and also the AMD 64 kernel mode patch, and basically catches up on all the FreeBSD patches.
Okay. So definitely some security updates here. So you'll want to upgrade your routers this weekend or sooner if you have time, but definitely want to check that out. Okay, well, now we got to get into feedback and questions, and we got a whole slew of them this week. So we will get started with that. And first up, it's Eric, and he asks about a VPN user access to only the internet. So he says, I want to let a friend in another country VPN into my pfSense router with OpenVPN to access some sports on TV. Is there an easy way to isolate him and give him only access to the internet and nothing else on my network?
Yeah. So in your PF rules, basically the VPN will show up as an extra interface, I think like tab 0 or something to that effect. And you, in your pfSense GUI there, will just be able to say he's only allowed to access the internet and not get onto your LAN. Just make sure that VPN's different IP set, and yeah, you can just create a firewall rule.
Should be very doable. So yeah, go ahead and give that a shot. Let us know if any problems with
It
that.
would basically work the same as if you had like a third NIC, so you can probably find a tutorial on how to do it on the pfSense forums as well.
Okay. Next up, we have Andrew, and he's asking about the differences between FreeBSD and FreeNAS. So he said, hey, guys, discovered the show a month ago. I think it's the best Nix-related podcast out there. So, of course, thank you. He said he's a longtime Linux user, but he's a recent BSD user. He said, I've currently been running a home server with FreeNAS. He's using 4 terabyte RAID Z. He said, I'm thinking of moving to FreeBSD to run my pool off of, and the main consideration for swapping is it'll give me a chance to better improve my command line foo. So he said, the question is, other than no web UI, what are the main differences I will encounter when moving and administrating my pool on FreeBSD compared to FreeNAS? Some pros and cons and any potential pitfalls. And would you suggest using FreeBSD current or stable?
So I sometimes FreeNAS is slightly ahead of the releases on features because they push them in sooner. So, but if you're running current or stable, you'll be fine there. FreeNAS just has some stuff built in, like automatically, email you when the pool detects a problem, and you'd have to just set that up on FreeBSD. But other than that, the FreeNAS is just FreeBSD with the GUI and some extra tools on top of it.
That's right. So, I mean, yeah, you'll be doing everything from the command line, which is kind of why you said you wanted to do this anyway. You will definitely improve your command line foo.
All of my storage servers are just vanilla FreeBSD because I want to be able to do other things on them, like run a beehive, although FreeNAS is gaining that ability. But, I just like, I've been doing FreeBSD so long. I know how I like everything, and I just like it that way.
Yeah, well, it's faster probably for you at this point instead of figuring out another UI.
Exactly.
Just, type, and done. Service up and running.
Typing is faster than clicking.
That's right. So, tracking current's a little more interesting. I mean, you could throw 10.2 on there. If you're running FreeNAS 9, 10.2 will be more current, I would guess, than FreeNAS 9.
Even half of my FreeBSD storage servers run head because there's newer ZFS changes in there, like the new resumable send. If you want to use that, then it's, you can, but yeah, running stable will be fine. And some of those changes will get backported there eventually. But yeah, I do run current on some of my machines just to get the new features. And also, my one FreeNAS server is also where I just happen to do my FreeBSD development. So it's very handy that it runs head.
That is good. Now, I do a mixture of current on the laptop and then release on everything else except for the build servers. Those are all current, updated monthly. But yeah, I like to have a little bit of both.
Yep.
Okay, well, next up we have a Joseph who writes in. He has a ZFS follow-up. He said, last week's show, Frank wrote in with an issue where he couldn't find his data on his ZFS USB stick. A while ago, I ran into a similar issue where I could see the space used by the dataset, but I couldn't see the data. It turned out that somehow it had become unmounted. Frank should check the mount point property for dataset and make sure it's mounted. His data is most likely still there, safe and sound. Hopefully.
So ZFS mount -A will just remount anything if it wasn't automatically mounted. This can also happen if you're on a vanilla FreeBSD. If you don't have ZFS_enable equals yes in rc.conf, then ZFS mount -A doesn't get run at boot up. And so while the pool's imported, none of the file systems get mounted automatically until you tell it to.
That's right. That's right. Okay, he also says, I was concerned about the dire warnings from FreeNAS about running ZFS in a VM. Is there any concrete evidence of corruption or any guidelines of what VM setups are and are not safe for ZFS? I've moved all my jails into a Beehive VM on top of ZFS, and now I'm a bit concerned. I'm using two 3 terabyte Western Digital red drives for this Beehive VM. Each drive has a single GPT partition covering nearly all the drive. Looks like I'm passing the raw partitions to Beehive as virtual AHCI drives. Excuse me, I couldn't read it there. He said, inside the VM, the drives are in a ZFS mirror on top of Jelly using the standard setup created by the FreeBSD installer. Originally, I tried to use Jelly on the host and passed the Jelly block device to Beehive, but apparently it doesn't work due to an issue with Geom. Both the host and VM are running FreeBSD 10.2. Does the FreeNAS warning about ZFS scrubbing in VMs still apply, or is it only an issue when you have RAID under the VM and only provide a single virtual drive that's backed by RAID?
I don't know the specifics of this one. We will have to try to finagle Josh Petzel to come back on the show and explain it to us.
Yeah, because that's going to be one people are going to keep asking us about. And honestly, that was the first I had heard of it.
Well, when I first heard of it, I was like, what? It was in the FreeNAS Worst Practices guide that they put up. And when I saw that it was written by Josh, I decided not to question it anymore.
Yeah, I'm sure there's some reason or a story.
Yes, I'm sure there's exactly. I know with Josh that there is definitely a story that this happened.
Yeah. So we had a customer who tried doing this and this and this, and that's how they blew up their data or something. So anyway, he said, I have 2 other 3 terabyte Western Digital red drives, and I'm considering them for a FreeNAS VM, but the FreeNAS website has scary warnings about running FreeNAS in a VM. While there are valid issues with virtual disk hiding stuff that ZFS FreeNAS would need, but not running properly in a VM is simply unacceptable these days. Everything runs in virtualization. If you can't, that's a problem. Well, I assume FreeNAS you can run it in a VM, right?
It really depends what you're doing. Generally, what you would do normally is you would have ZFS running on the host, and then the VMs would just have a regular file system and it'd be protected by ZFS. But I can definitely see why you would want ZFS in the VM to use the administrative parts of ZFS. So yes, we will have to try and get in touch with Josh and see if he can't tell us the story behind that and clarify exactly what the issues are.
Okay. Let's see. Next we have Sean. You want to read this one?
He writes in about hardware support. He said, I'd like to say that I've already swapped to BSD, but I haven't. Every time I hear an episode of your show, I go, awesome, let me try that. But BSD support seems to be where Linux was 10 years ago. I've always 2 or 3 generations behind in hardware at the moment. He says he's running a T440p Lenovo ThinkPad with an MSI big long string of numbers. I don't know what that is. Is that supposed to be a video card?
I don't know what that is. I don't recognize that.
Or maybe it's the motherboard. Anyway, he says, problem, both are Haswell. At this point, Linux pretty much works with everything Intel, but BSD doesn't. So, do you have the release of PCBSD with the Haswell stuff yet?
We do. Our November images, which just went out last week.
So if you grab the November image of PCBSD, it has the FreeBSD Haswell support. There you go.
Problem solved.
Anyway, Intel Wi-Fi cards in both, no support. I wonder which card he's got. Is it the 7260 maybe because it's newer?
You may need to try also the November image.
Yes, the November image has the Intel 7260 support as well. And the Intel graphics. I think essentially getting support for ThinkPads would be good for getting business people with laptops. Yes. So a T530 works, and just a T540 doesn't. But actually, in head, the T540 should work. However, T550 might be a couple more months before we have the graphics going.
Sure.
So yes, we're not 5 or 10 years behind. We're 2 generations behind, which is like 2 years maybe. But we're working on it.
It's getting there. It's getting there. They've brought the support up finally to the point where they're starting to move on it a little quicker.
Yeah. So yes, what does it work on besides servers? Well, it turns out that anything that's not anything before Haswell. So your Standy Bridge and Ivy Bridge will work great. He says he tried on about 20 different laptops and none of them have supported. And most of the hardware is about 2 generations behind the latest, which is now Skylake after Broadwell. It says what an Asus K55 with Haswell. Really, anyway, manually upgraded to max out the specs, and he used that. So I'd say in general, if it's a desktop, then if you just get a real graphics card that says NVIDIA on the box, then it should work. That's what I've done. But
same here.
yeah, my T530 and my X220 work very well, and my girlfriend's X230 works as well. But your T540p should work if you try out PCBSD's November snapshot, which has the new code that finally went in. Well, actually, the Haswell graphics is not even actually in FreeBSD. It was just manually added to PCBSD.
We just built off the development branch.
But the Wi-Fi driver is, right? The 726 IWM is in FreeBSD and works. So hopefully this means that your laptop now works. And it didn't take 10 years to get there.
That's right. That's right.
Maybe it took a year or two longer than we hoped, but it is, the work is being done finally.
I'm hoping 11.0 hits, that'll change a lot of this and start moving a little more rapidly.
Hopefully, if we could be fast enough, could it get into 10.3, which is like March-ish?
As long as it all gets backported, it hasn't even landed in current.
If we get it in current, and then we can get it backported, and it doesn't break a whole bunch of things, then this hopefully will be in the next 2 releases of FreeBSD, which are the first half of next year. So yes,
that would be fantastic.
We realize that things got slightly behind, but we're making, people are working on it, and the effort is being made, and the results are finally hitting as well.
Okay. You want to read the last one here? We got Dustin who writes in about alternatives to Puppet.
Yes, he says, hi guys. I've heard Allan talk about how he uses Puppet as scale engine, but that if he got to do it over again, he would pick a different orchestration platform. He says, working on my home network has been an ongoing hobby of mine, and listening to BSD Now has helped me replace many of the services like the firewall, storage, DNS, VPS, etc. with FreeBSD. A recent count of servers that I use, including jails, came out to about 20, and I was wondering if you had any pointers on getting started with orchestration. My apologies if you guys have already covered this in the past. And he says, even if it isn't 100% practical, I'd appreciate any pointers just to quench some of my curiosity on how orchestration could help make managing all these servers easier. So for that size, you could use Puppet, but SaltStack seems to be what most people recommend. But Ansible, I know a lot of people like as well. Especially for smaller, simplest setups, Ansible seems to be quite popular. SaltStack seems to be slightly more featureful, but either Ansible or SaltStack, both of them should have quite a few tutorials on how to do it on BSD. I know that both Dan Langell and Michael Dukas use Ansible and have written about it on their blogs. But I also know that there are like Limelight Networks, which is a big CDM with like 10,000 FreeBSD servers, uses SaltStack. But the Groupon people use Ansible, but they use it inside of a bigger framework called Console, which is to work around the limitations of Ansible.
That's a whole other thing.
But those are the 10,000 plus server scales where, for your scale, Ansible might be the easiest and the quickest to learn, but SaltStack is what I am looking at going to for our 150-ish servers here at Scale Engine.
Nice. Okay. Well, thank you guys all for writing in. And of course, if you'd like to send us a question, we would love to read that on the air and try and answer that for you next week. So as usual, as we wrap up the show, try and send anything you have over to feedback@bsdnow.tv. That could be a question, a comment, a technical question about anything. Or if you have a show idea or a topic or some story you found that you think needs to be mentioned on the show.
Somebody's blog post, whatever.
Yeah. It take you 2 seconds. Literally just copy, paste a link, hit send. We'll read it and figure out where we can put that in the show. Especially if it's something maybe we wouldn't run across in our normal day-to-day here.
And that's what we try to tell people, would be like, oh, you didn't cover enough OpenBSD this week. It's like, well, I think this week we did quite well, but
Sure.
If you feel there's not enough OpenBSD, send us more OpenBSD stories and we will cover them.
And because we're doing the Beastie Bits section now, it doesn't have to be something where we have to spend a lot of time talking about it. If you just find something really cool, like the screenshot of booting the 75 megahertz Cyrix up on OpenBSD, or the fact that NetBSD has Amiga support with X now, like send it on in. We'll try and get it mentioned somewhere. So
we'd also love to see more stories about the cross-project collaboration stuff, like the recent one we talked with Baptiste and Dragonfly. So if you happen to know one of these stories and it's not posted somewhere, write a blog and send it in.
That's right. So again, try and send that in to feedback@bsdnow.tv. Don't leave comments necessarily on YouTube. I mean, you can, but we're not necessarily going to see them. So try and send it into the email there, and we will get you in a future episode. So thanks again for watching this week, guys, and we look forward to being back at the same time next week.